algorithms for searching to solve problems that are computationally infeasible for classical computer. And also in quantum artificial intelligence, now we have also developed quantum machine learning. It's a machine learning similar, but it's quantum machine learning. It has different algorithms, different approach of computing, different coding, different data processing, and outcomes are different, and applications are also different. So there are new quantum machine learning algorithms have also been developed, like we have quantum support vector machines, quantum neural networks, and so on. So with this quantum artificial intelligence, uh, because it's combining two most powerful technologies in the world, combining two most important powerful technologies in the world is one is quantum computing, the other one is artificial intelligence. So quantum artificial intelligence is probably the most powerful technology in the current world, because it has the quantum technology, quantum computing power, and also on the other hand artificial intelligence power. So this quantum artificial intelligence now increases substantially thousands in the benefits of artificial intelligence, but it also increases the risk of artificial intelligence that we have discussed before. So now, therefore, we have a very powerful technology that which is quantum artificial intelligence. It gives a lot of benefits to us, but it also increases of different uncertainties. The benefit side, quantum artificial intelligence exponentially speed up computing, artificial intelligence, machine learning in the areas such as optimization, cryptography, drug discovery, and financial modeling. But as I said, it is also increases the risk. So in the summary form, if the benefits are higher and the risks are higher, so what is the future of mankind? Because there are a lot of uncertainties. In the summary form, we don't know. Nobody knows. That is the bottom line. We don't know. We know what is going to happen to the world and human being in the future. So to manage this problem, we can use the game theory approach. The game theory approach is the mathematical model which gives a to uh, solution to different relationship or complicated problems. If we develop quantum artificial intelligence development strategies based on game theory modeling and strategies, then many people, including me, I think that there is a hope that will be able to minimize the risk of uh, quantum artificial intelligence. The I will not go into the detail of the game theory aspect um, uh, because I work in this area, and I have a good number of publications, and if people are interested to collaborate with me in this area, then I will be happy to support, mentor, and collaborate with the other people. And so this is the summary form, the presentation. If you want to know more of the technical side of the applications of quantum artificial intelligence, then I can open another slide. Otherwise, we can go to the question and answer mode. Should I continue or we go to the course, the question and answer?
You can continue, sir.
The So this, in quantum artificial intelligence area, one important area for technical work and understanding is the quantum machine learning. Advanced quantum machine learning, and because quantum artificial intelligence is the general concept, but it's a real life application. We have to develop quantum machine learning technologies, algorithms, programming, and also application in different areas. Uh, the the quantum machine learning is like the quantum machine learning. In this approach, this is the most technical area in quantum artificial intelligence. We develop quantum machine learning like normal machine learning, using quantum computers and quantum programming and quantum algorithms. So, and in this area, it will be different from classical machine learning because there will be differences in quantum processor, quantum gates, quantum annealing, and also the hardware system. They are different. So in the quantum machine learning that we develop, that is different from normal machine learning. Why we use quantum machine learning? Because they give much more better powerful machine learning platforms our performance if we develop quantum machine learning. uh, the 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 benefits of quantum machine learning and general quantum computers are enormous. They have increased their computational power, increases speed, helps to solve large scale problems that cannot be solved currently. Breakthrough, it can also develop different breakthroughs in science, engineering, material science, drug discovery, climate modeling, and which cannot be done using current computers. And also it can gives also increased enhanced cyber security because of the power of quantum machine learning. So and then to develop quantum machine learning, we need to do quantum programming. So doing quantum programming, we have two options. Either we can directly use quantum computers, um, uh, otherwise we can use the current classical computers and then simulate the quantum computers to start quantum coding and programming. Um, and then we have to we'll develop a programming environment suitable for implementing large scale quantum algorithms. And there are different quantum languages which are different from classical computing languages, except the Python can be used, but there are different the development kit is completely different from classical programming environment. So the the most popular quantum programming languages and tools which can be used for quantum artificial intelligence and quantum machine learning are the following. Like these are also Python based, but they cannot be used for classical computers. They are only developed for quantum computing and quantum computer. And these are Qiskit, SARC, Forest SDK, and others. And we need to this Qiskit is developed by IBM, SARC is developed by Google, and Pennylen for quantum and machine learning is also the very useful platform for doing quantum programming. The quantum hardware, still there are some problems in the real quantum computers hardware. There because there are noises and problems, but the error correction has developed, and it is expected that these problems will be overcome in the near future. And as I said, the quantum computing approach is completely different from classical computing and programming and algorithm development. In quantum computing, we have to start to first develop a circuit. And first we have to understand that develop the algorithm, and algorithm can give us the circuit that should be coded and using quantum computer programs, and then we can get the result. So the for example, if we write a code using this Qiskit, the IBM Qiskit code is a zero sum game theory based model for cyber security using quantum machine learning approach to detect cyber security. But we can detect cyber security attack. We can use normal machine learning, but this code is showing that we can also use the quantum machine learning approach, which can be much better than the classical approach to detect a cyber attack using the quantum machine learning or quantum artificial intelligence approach. So this is just an example. This is possible. This is not it is not a hypothetical. And in quantum computing, the quantum machine learning has developed a lot. This is a very well-established area, and because the quantum machine learning, like normal machine learning, has many applications, possible current and possible application. So therefore, this is and by adopting quantum machine learning approach, we develop quantum artificial intelligence, and that can be used for different different industrial, financial, health, and other benefits. And this quantum, the in quantum machine learning, the algorithms are different from normal machine learning algorithms. Some of the quantum machine learning algorithms are also discussed here, like Grover's adaptive search algorithm, variational quantum eigen solver, quantum optimization algorithm, quadratic unconstant binary optimization, quantum approximate optimization algorithm. And so these are not normal algorithms, normal machine learning algorithms. These are quantum machine learning algorithms. So this quantum machine learning also, this is the area of in quantum artificial intelligence. So the machine learning can uh, perform different tasks, as we know: prediction, classification, decision making, analyzing information, and quantum machine learning, and also the other tasks the machine learning can perform. Quantum machine learning can also perform the same task. But quantum machine learning also have some increased advantages. It can solve many complex mathematical problems that current machine learning cannot solve, and it has a better application in feature selection and also gives a better neural networks and so on. And quantum machine learning, can be applied in all the most of the areas where the classical or current machine learning algorithms and platform are being used. So the programming, the quantum computing is an extremely difficult subject. Yeah, because for many reasons, because to learn quantum computing, somebody has to have some knowledge of quantum physics, quantum mechanics. That's one part. Second part, quantum computing is based on quantum mechanics. That means it's a very mathematical subject. So you have to know quite advanced mathematics, but it's not only the quantum physics or quantum mathematics, but the programming is also very technical. It's not normal classical programming that we do is start writing Python on the computer, because the in quantum programming we have to develop first the circuits, and then we have to also use gates, and also develop the quantum physics principle to data analysis. Uh, because the normal data that we use in classical computer, like 1 2 3 4 5, this data cannot be used in quantum computing or quantum programming. Therefore, we have to change the classical data into quantum state through this sort of circuit development, and then we have to do the parameterize the model, develop the circuit, and then convert the classical data into quantum data. And when after do computation and then convert back to the convert back again to classical data, then we can understand what is the result. There are different complicated gates through which we have to do the coding. Some of these gates are look like that. So if we have to develop a quantum neural network, coding and programming, and that is it will go through this sort of steps given here, and finally we can develop a code that will solve this quantum neural network problem. And in the one that is this is based on Qiskit of IBM, but then we can also use PennyLane to develop quantum machine learning. The the algorithm and platform. So these are also possible. um, and there are the other sort of different circuit that we need to develop also, and then the area of application of quantum machine learning, uh, quantum technologies and quantum computing in general. This all areas of engineering, quantum machine learning, quantum artificial intelligence can be applied. For example, fire modeling, quantum business and finance application, the quantum health, quantum material science, quantum energy, manufacturing, transport, and so on. And many of these areas already research and development have progressed, and technologies have been developed to apply quantum machine learning and quantum artificial intelligence. And there are the quantum machine learning, as I said, quantum artificial intelligence is a very advanced one, very well developed area in quantum computing. And already some technical, very advanced technical work has been done. The different technologies and programming and algorithms have been developed, and applications have also been made in different areas. This quantum machine learning can be used and are being used extensively also in the computer science area, quantum computer engineering and computer science area. Um, One area in engineering is fluid mechanics or computational fluid mechanics (CFD), and this area quantum machine learning is also being used extensively to develop a better system of CFD. And as you know, CFD has many applications in engineering. And then there are for research for companies for real life applications. We can use quantum machine learning, but we have to develop some strategies and plans how we can use quantum machine learning technologies. We need to develop the skills and knowledge capabilities, and we need to have the hardware. Somebody needs to know also the software side, and do the experiments and develop machine learning algorithm technologies, and then this can be applied for a real life cases and so on. So there are still some problems in quantum hardware side, but things are progressing very fast, and we are hoping that in the near future the error-free quantum computers will be commercially available. And the quantum computing or quantum physics, quantum mechanics, people say this is the most important invention by human beings. And for that reason, the United Nations is celebrating 2025 as the International Year of Quantum Science and Technologies. So United Nations has uh, has considered and has classified 2025 as the International Year of Quantum Science and Technology. So you can see how important is the topic, the quantum topic, quantum physics and quantum computing, quantum technology. And it is expected that the quantum computing, quantum technologies will change, the human being, the earth, even the universe substantially. And this is an important area for contributing to the world, to industries, for doing research and career development for international collaboration. And this is my interest, my mission to be a quantum activist. The people to make them aware of quantum technologies, quantum computing, quantum artificial intelligence, quantum machine learning, and so on. And because there are many, fundamental, substantial benefits for applying these technologies to improve mankind and improve the world. So I'm out of my passion. This is my passion. I'm happy to collaborate and mentor or involved in different projects or activities, especially in grants, international grants, training, short courses, PhD supervision, publications, and so on, for industry application. If you have any comments, if you have any proposal, you can send to my email. My email address is given here, is shordar.islam at bu.eu and .au. So thanks for your time, and I'm happy to give any question to your answers. So as you know, this is my area of expertise. I have publication, PhD supervision, and I'm also planning to teach quantum computing subjects. Thank you.
Sir, thank you, sir. Thank you. Audience and participants, any questions? Dear participants, I think my voice is audible to you all.
Yes, sir.
Please, if you have any questions or want to interact with the guest, please.
Sir.
Okay, thank you. Sir, any from our participant side?
Sir, good evening, sir.
So
Hello.
there is one question from chat box, sir. How to pursue doctorate in this? From Sakil Akamat. He is posting that chat box, sir. How
Yes.
to pursue postdoctorate in this quantum technology?
There are many postdoctoral positions available around the world, including India, Australia. In Australia, we have the government science organization called CSIRO. They also offer postdoctoral positions in quantum computing, quantum algorithm. And if somebody searches postdoc in quantum area, they will be able to find it. Otherwise, they can contact me. I can give some specific websites.
Yes, Sai is given the ID, email ID. Please contact to Sir Professor through mail ID. And Hemlata, madam, you are asking any question? Dr. Hemlata.
Sir, what sort of collaboration you are expecting, sir?
Anything. We are academic. I'm not expecting. I'm available. It's just saying, because this is a new area. If people need any help, especially for mentoring, PhD supervision, giving training, short courses, because in India, as you know, the measure a very substantial amount of money now allocated to quantum technologies. And even the prime minister and also the other expert in that, they are trying to make India a leader in quantum technology area. There are different research institutes developed. Many funds are allocated, and there are different initiatives. So same is the case everywhere in the world. Australia also allocates a major share of their research fund for developing quantum technologies, because the country, nation will be the leader in quantum, will be the leader in the world. So that is the situation, because the quantum leadership will give them leadership in all areas of in the global framework. So in that area, if people need any a sort of support or need to do any project, because I have publications, I have the computer programs, I have PhD students, so I have the capabilities for helping people, training people, teaching quantum computers. So I'm happy to collaborate, mentor, or cooperate in any form necessary, from industry application to research and publication, or even teaching or short courses. It's a bit out of my interest in quantum computing area.
Thank you so much for your explanation, sir.
Any questions?
And as I said, if you search by name, you will find hundreds and hundreds my website, and it will be easy to find my contacts through different social media or just internet. So if you have any questions, comment, you can always send your questions or comments to me uh, through different platforms.
Yes, thank you, sir. Thank you, participants. And first of all, thank to our guest, Sardar sir. It's a great session for us. And due to some technical issue, we are starting some delay in that. But even though sir is given brief information about the technologies or algorithm related to quantum computing, and he has given guiding many research related projects and higher education for postdoctoral and guidance and all. This will be helping for us. Sir, thank you for joining with us, sir.
Okay, thank you.
Thank you, sir. And all the participants, thank you. That after this session is, we are posting the feedback link onto the WhatsApp. And one more session we started in the June. Once again. Yes, in the same MS Team platform. Due to some technical reason only, we are started in this Google platform. So again, we go for MS Team and for the next session. Thank you all. So thank you, sir. Thank you.
Thank you.
Thank you, sir. Thank you. So thank you all. We will wind up for this session, and again we go for session 8 in the Zoom meeting. Thank you. So not Zoom, it is MS Team. Thank you.